students. Let us continue with our makeup class today. I'll do a quick review of Python operators so that we'll get use of it. I know we have done this in class, and I mentioned it briefly in the last video, but I don't know how much of it you got, so that is the reason I will quickly review it. So in Python, the basic arithmetic operators also works exactly the way you know it, which is addition, subtraction, multiplication, which is represented as asterisks, and then division, which is /. So what you may have not seen, however, is this, which is exponential. This again, which is floor division. It is called floor division. And this, which is called modulo operator or modulus operator. You understand? I will explain them in a bit. But from what you already know, if I copy this, sorry, I want to go to Python IDE for demonstration. Yeah, so if I paste that here, then I would have can take out this. Yeah, so that's the comment, by the way. Remember comment. So that part won't run. So we can do print 4 plus 4, or better still, let us create variables. So we'll say that A is equals to 10 and B is equal to 5. I think that is better. So we can then say print A plus B to make it more. Well, we already know f string, so let's use f string to do everything we want to do all of our printing. So we just say, sorry, this should go inside here. So we can say addition results is A plus B. And let me copy this, and then I'll copy this and go to the next line. I'll say subtraction. Result will be A minus B. If I move further and print, this would be multiplication. Multiplication results. This will be A multiplied by B. And then finally, this will be division. So just say A divided by B, sorry. Yeah, so if we save this and we run, let's look at our results. So you see A plus B is 15, A minus B is 5, A times B, which is 5 times 10, is 50, and again A divided by b is 2.0. So look at how the multiplication result returned floating points data instead of integer like others. That is to tell you that by default, division are meant to return division outputs or division operation returns floating points data by default. For instance, if we say, if I copy this here now and I come here and say, I paste the print, but then up here I put type. Let me close that brackets. So if we run this, you see, oh, of course, this is a string, sorry. Yeah, because it's f string. I'm printing the f string. Sorry, don't mind me. So that should be here. Let me see what happens if I do that here. Type of A divided by B. You see, it is floats. So it still prints division results, but now it is the type because that is what I asked it to do. You understand? Or better still, I can save that here. You understand? But you know, for that to work, I need to bring this here. Let me run this and yeah, that is syntax because you know why. There are two lines, but it needs only one. So let's copy it one by one. We had such error in last class. So now we can then save results to a variable by saying, let's call it div results is equals to a div result is equals to, just a second, div result is equals to a divided by b. So now we can say type div results. See, it is float. I think this is more understandable, right? So now we can confirm that by default, division operation always returns floats. All right. So this is all about basic arithmetic operation. Now we have another thing here. We have these three other operators. If we go back to, but let me briefly explain what they do. So this, let me do this. 1, 2, 3, 4, 5, 6, 7, focus. All right, so that is going to put my DND on. So this sign here, if I copy it, is called exponential operator. Exponential operator. That is powers. So this is how you can raise, if you do 2, this is something like saying 2 raised to power 2, which will be 4 because 2 times 2 is 4. If we do 2 raised to power 3, this will be 8 because it will be 2 times 2. It will be 2 times 2 times 2. You understand? So That is what that does. That is what it does. Sorry about this. So it is raised to power. So we can test by doing, I just do that here, 2 exponential 2 exponential 3. You understand? So again, this is called floor division. Yes, this is called floor division. What it does is that you have seen the behavior of the normal division. It returns a floating point output. So, but floor division will truncate the floating point part and return only the integer. You understand? So if you have 2.0 as output ordinarily from normal division, floor division will return 2 instead of 2.0. You understand? Let's test that. For instance, already now we have A over B here. So if we do A divide floor division by B, you see, it returns 2. Remember that ordinarily A divided by B returns 2.0. So it truncates the decimal parts, you understand, and return the first, the only the integer. So, and the thing is that, so see why this is important now. If I print type A floor division B, see, it returns an integer. You understand? So depending on the scenario, you may want your division, the output of your division by the time it is returned to be an integer. You understand? Or for some other reason, you don't want the decimal parts, you understand, to be included. You just want the first point there, the first number that is returned. You don't want the decimal part. You can use floor division to achieve that. Understand? Remember typecasting, remember typecasting. For instance, we can take this. If what we want is solely solely to return an integer, type, then inside here I put int, I close this. You understand? So I want to see type that it will be. See, integer again. You understand? When ordinarily this is supposed to return. Let me remove the type. So let's see what happens. I'm not checking tag. I just want to typecast. I don't want float to be returned. You see, it returns the first part because I want integer return. So pay attention to all of these things. It looks like I'm wasting time there, but these things are key to understanding programming. These basics really matters. You understand? So lastly, we'll look at the modulus operator. This is called modulus operator. The operator is represented by percentage sign. See, it's called modulus or modulo operator. So I think modulus is probably 1 modulus, the past plural, or I'm not sure, but that is it. So what this does is opposite of what what the floor division does. You understand? So it returns the remainder. You know, when you have 10 divided by 5, if you have 10 divided by 5, it should return 2.0, right? Good. Meaning for this, nothing is remaining. There's no remainder because 5 perfectly divides 10. But what if we divide 10 by 3? Let's check. If we do print A divided by 3, you see what the result is. Of course, 5 dividing 3, 10 dividing by 3 will be 3, 3, 3, remainder 1, right? So now let's use modulus operator to divide this, you see. So if we now do print A modulo 3. Sorry, I made a mistake. Yeah, but if we did this, let's say we did 2 divided by 3, you have 0.166. Okay. Sorry, let's do what we wanted to do initially for a more perfect example. You know that is fraction, and that is why it's returning that. So if we did A, that's what I wanted to type. I want to type 2 divided by 3. So you see, this is the original result. But if we did A modulo 3, you see, it returns 1 because what is returning is the remainder and not, you know, it is the remainder that it will return. You understand? So be careful on how to use these things. I will explain to you where this comes handy in the course of this lecture. Just pay attention as we go. I can see how many times the time I've spent. All right, so that is that about operators. Let's go to, my arithmetic operators. We have explained all arithmetic operators. Let's look at comparison operator. Comparison operator. So this is comparison. Let me take them. Let me take from here to here. It is used to compare values. And go back to our file again. Comparison operators. So this checks if something is equal to another thing. For instance, print A is equal to B. You know, this is a Boolean value. So in this comparison operator, it will always return a Boolean value. For instance, we already have A, and B here. Let's say print A is equal to B. You see, it is false. Why? Because A is not equal to B. But let us create another variable, C, and say that C is equal to A. what have we succeeded in doing? We have assigned the same value of A to C. You understand? Both A and C is pointing to the same value. So now, if we say print A is equal to C, what do you think will be the output? True, of course, because A is equals to 10 and C is equals to 10. You understand? So the same way, this is not equal to. You understand? So if we take this, well, of course, if I take this, which we know that is equal, and come here and say that it is not equal, to be false, because it is equal. If we take this, however, sorry, I paste this again, but this time around, it is B that we're comparing with, and we say that A is not equal to B, and it's going to print truth because 5 is not equal to 10. You understand? Remember our value, the values of our variables. You understand? So this is greater than, this is less than. This is greater than and equal to, this is less than and equal to. These are comparison operators. You understand? So we can add our first, F string here and cover this in curly brackets. And then we say equal to, A, or rather, A is equal to B. It will test, if that is true or false. And then we'll just paste here. We have 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. So here we will check not equal to, and we'll do the same here. And here we will check greater than, right? Greater than sign. If it is, the right result will be returned. And then we have less than. Check the same thing here. So comparison operator usually only returns Boolean type. The other one is greater than or equal to. Yeah, greater than or equal to. Why this is less than or equal to. Less than or equal to. Let's add one more here. Yeah, where we are saying, where we introduce C this time around. Saying A is greater than or equal to. Greater than or equal to. We can also test here C again, saying introduce C here, and we check if A is equal to C. So if we save this and run, we have a mistake somewhere. C is not defined. That is true. We did not define C here. So now we save and we run. So you see, this is false, this is true, this is true because A is not equal to B. A is greater than B. This is true. This is false. A is not less than B because it is greater. Then A is greater than or equal to B. You understand? So two things here. It is either this or this. This is also either this or this. It is neither equal nor less than B. That is why it is returning false. Yeah. But here, why do you think it returned true here? Because A is equal to C. It is either greater than or equal to. So as far as one of the conditions is true, the output will be true. You understand? So that is that about comparison operators. Let's go to logical operators. Logical operators. I will bring this up and take this down. So logical operators are and, or, and not. They are used to compare I used to combine conditional statements, we will treat conditional statements here, but I'm just reviewing this. We will see how this works. But let's say we have a condition. You see the same way we have where something is either less than or equal to or greater than or equal to. That is how this or works here. We're going to be having some exercises in this course today where we are going to be asking users to input some data. You understand? So we can check if the data they inserted is A or B. You understand? In this case, if any of them turns out to be true, the condition is true and it will run. You understand? So if the input the user puts is either A or B, that will work. But this is different from AND. The AND operator says that if the input from the user is A and B, what this means is that both of them must be true for this condition to be true. You understand? The same for the not is like negating. Okay, it was this people into other level that I thought digital logic. You understand? So if something is not true, then it is false. You understand? We will deal with this more as when we go to conditional statements. So let's move to assignment operators. You understand? Assignment operators. We have seen this first, where we use this to assign variables. A is equal to this, B is equal to that. One other thing we can do is let's copy that. Let's copy this. Assignment operators. So we have seen A is equals to B, C is equals to A, and all of that. Now, if we want to increment A, for instance, so we want to say A is equal to A plus B. What do you think the answer will be? 15, right? Meaning that at this point, if we print A, We have 15. Now, this is the new A. What if we want to also add something to the new A? Maybe we say print A again. Our current A at this moment is 15. So we want to say A is equals to print A, or rather, before we print it, okay, let me print and see what happens. A is equal to A again plus 5. Yeah, we can't do that inside. We can't do that inside there, but we can say A is equal to A, sorry, plus 5. Now, if we print A again, A should be 20. Now, instead of doing A is equal to A plus 5 again, which will now bring A to 25, we can do A plus equal to 5. If we print A now, A becomes 25. You understand? We can do again. You understand? So it is a short form of writing A is equals to A plus something. What you want to implement it by. The same thing with a minus or subtraction. So let's say we want to return A, we want to decrement A by 5. Again, you can say A minus equal to 5. So A in this form now will be, at this moment, A will go back to 20. You understand? The same way also, multiplication. We can say A multiplied by A times 5. A is equals to A multiplied by 5. That is what we are essentially saying. But we are writing it in short form. So at this moment, we expect A to be what? 100. You understand? The same way also, we can divide. Just a short form of writing. So we can say A is divide equal to 5. You understand? By this moment, A should return to what? If we print A now, it should return towards 20. And as usual, division operation returns floating point data. So this is how this part works. We have seen it here, so no need to do this again. And then now we can go to membership operators. To tell you about membership operators, let me introduce you to a kind of data type we have not talked about before. I'll briefly introduce it, but we'll deal with it later. You understand? There's a kind of data type or data structure in Python called lists. Lists like this. So you cannot use lists because it is a keyword in Python. You can't use it as a variable name. You understand? But we can say list1 is equal to, let's say we want to gather a list of fruits. You understand? So what you use to know a list is that is square brackets. They are covered in square brackets. That is a list. So we can say this is apple. This another one in our list is banana. And then the third one is eyes is not orange. So let me take this now. But just before I go to demonstrate, we can use this membership operator like in and not in to check if let's say we are asking users we designed a program that, gives users any kind of fruit that they want, as far as we have that fruit. Eh? So the program prompts user to enter the fruits they want to take, and when they type mango, for instance, we'll first of all check if mango is among the fruits we have in our lists. That is how we can use this to check. If it is there, it's going to print yes, true or false. If it is not, the same thing. So let's copy this and go to our code to demonstrate. So okay, let me just go straight here so we don't waste time. Why is that? Syntax error, invalid character. Oh, so you see, the problem here is that the my quotes in that my Canva is different from what is seen here for Python as code. So let's correct it here, and then we can copy it back. You see, now they look like what it should be. So now I save it and we don't have issues again. So we can check, we can print lists. Print list one. Print list one. See, and it prints this. And we can say print apple in list one. See, it says true because there's apple there. If I say print eyes in list one, it says false because we don't have such. You can also say print eyes not in list one. I'm going to return true because it is not there. So that is all about membership operators. Finally, let's look at identity operators. So this one is and is not. You understand? You use it to compare memory. Identity operators. Identity operators. So copy this and go back here. Identity operators. So you remember when we said here that when we assigned A to C, this also returns Boolean, either true or false. So if we say print A is C, well, it is now false because our A has changed. This is as it is here now. Our A is currently 20. If we print C, you will see that our C may still be 10. It should still be 10, you see. But now, if we say C is equal to A, now, meaning that our A is 10, we can bring back this again, print A is C. And it says true because A is C. A is 10, C is 10. We can say print A is not I, and that is true. Well, it does not know what I is. let's say print A is not B. At least yeah, it knows B. And that is true because A is not B. So that is how this other operators works. Let's move ahead now. Some of that I will still explain as we go into. But let's look at another very important concept in Python, and that is the order of precedence, operator precedence in Python. Operator precedence in Python. You see, if you remember board mass in your secondary school days, board mass, where bracket says do me first. The same way, the way we refer to this, it is the same concept, but the way we refer to it in programming is PEMDAS. P-E-M-D-A-S. PEMDAS. What this means is P is parenthesis. P is parenthesis, which is brackets. E is exponential, which is powers. If you remember, the exponential is double asterisk. Exponential. While M is multiplication, which is one asterisk. D, on the other hand, is division, which is forward slash. A is addition, while S is subtraction. So what this is essentially saying is that if you have 5 in an arithmetic operation, if you have 5 plus 2 minus 1 raised to power raised to power 2 times 5 divided by 2. We have represented all the arithmetic operators we needed. Oh, okay, well, let's also say, put this here. So 5 plus 2 is in brackets. So what PEMDAS rule is saying is that the parts of the arithmetic expression that has parentheses, which is brackets in it, will be evaluated first, followed by the part that has exponential. You understand? In this case, that will be this part. So this is evaluated first. This part will be evaluated second because it is exponential. Then followed by multiplication. This part is multiplication. So this will be evaluated third. And then division will be followed. But I'm going to show you something. This is division. This will be evaluated fourth. But I'm going to show you something just now. Before addition and subtraction will be attended to. So addition will be evaluated fifth, and then subtraction will be the last one to be evaluated here in the sixth order. This is the order at which Python evaluates mathematical expressions. But what I said I'm going to explain to you about multiplication and division is that multiplication and division have the same precedence. So if you have PEMDAS, written vertically, let me change the color of my pen. Multiplication and division have the same precedence. The same precedence, while addition and subtraction also have the same precedence. But multiplication and division will be evaluated first before them. So multiplication and division have higher precedence than addition and subtraction. But parenthesis has the highest precedence, followed by exponential, that is powers. So what this means is that if, based on our arithmetic expression that we have here, this will be evaluated first. So we then have 7 minus 1 raised to power 2. Any number raised to power 1 raised to any number is still 1, Abi? Because 1 times 1 times 1 times anything is still 1. So this part will be evaluated second. So we have 1 here. Then we then have 1 now. Okay, yes. So we now have 1 multiplied by 5 here. And then divide by 2. In this second part now, this is not a mathematical class, by the way. You understand? So I'm using this to explain something to you. I may not have formed the question very well, and so on. But I also make mistake, but that is not the point. Understand what I'm trying to explain to you. So at this level, we have multiplication, we have subtraction and division. Subtraction and division have the same order of precedence. What does Python do? When operations that have the same order of precedence appears in when they appear in an arithmetic expression, Python then evaluates it starting from the left to the right. Meaning that what will happen here is that we will have 7. We will have 7 minus have lower order of precedence, so it's not evaluated first. You then have 1 times 5. So here we will have 5.
Yes.
Then we will then have 2 divided by 5, which will give us 2.5. Abi? Yes, 2.5. So yes, so if we rewrite this again, or let's still put our 2 here. You understand? But yes, that is what will happen, because Python will first of all evaluate, because it will see multiplication. So first, before it sees division. So it will first of all evaluate it before it finally then meets division. So it will then evaluate it in such a way that what you have here is 2.5. Yes. So before it will now finally evaluate 1 minus 2.5. Sorry, 7 minus 2.5. You understand? Like I said, I may have not formed this expression very well, but you understand what I'm trying to explain. So this is how Python evaluates arithmetic expressions. Just keep this in mind, PEMDAS. That's will save you tomorrow. So what this means is that depending on the result you're expecting from an expression, you can use parentheses to force a particular part of that expression to be evaluated first before any other parts. You understand? This can now come to be powers or exponential. But instead of based on PEMDAS, this is now evaluated first before this part is attended to. So you then have, what it means here is that you have 2 raised to power 2 here. Sorry, 2 times 2 is 4. So 4 raised to power 2. Yes. So this is very important, guys. You understand? For instance, let me use this to show you. Just very quickly. If we do result, for instance, is equal to 5, or rather 10 plus 5 times 2. Times 2. What are we expecting? We're expecting 20, right? Because 5 times 2 will be 10. 10 plus 2 will be 20. So let's print results. That is 20. Now, what if we now do res? Let me just do res. Let me call it res. Is equal to, or rather, you can just print. We have seen what results gave us. So what if we now print with our f string again? Let me add with parentheses here, just so parentheses, just so it makes what you are printing clear. So now we know that here this part was evaluated first based on order of precedence. But if we introduce parentheses here now, this is now, sorry, 10 plus 5, the same results, the same expression, multiplied by 2. Now, sorry, let me close this. Now, this parenthesis will force Python to evaluate 5 plus 10 first, which will be 15, before it multiplies this by 2, which will now give us that. Let's check. Oh, I did not close. This is this. This is this. And then this. It is okay now. Let's see. What did I do wrong? Oh, I didn't close the parent. Sorry, quotes. So you see, with parentheses, this result that gave us 20 before is now giving us 30. That is what order of operation can do. You understand? So please, guys, let's pay attention to this.